has done in the modern world is that we scientists ask questions, and we let nature give us the answers. That absurd interpretation is that the Earth, all life, and the universe is 6,000 years old. Now that is inconsistent not just with biology and evolutionary biology, but it's inconsistent with everything we know about the universe. Absolutely everything. Chemistry, physics, biology, geology, astronomy, absolutely everything we know about the universe tells us that this is nonsense. Science makes predictions about the world. Predictions that can be tested, and predictions that impact upon our lives. Predictions that allow us to develop new vaccines against diseases. Predictions that allow us to develop forms of transportation that take us around the world. If you believe the Earth is 6,000 years old, then you have to renounce all of science. And in fact, you shouldn't be flying in airplanes, driving cars, listening to the radio, because the very physics on which all those things depends tells us that the world is far older than 6,000 years old. First of all, the Big Bang really happened. It's not an invention, it's not a hypothetical thing. In fact, last year's Nobel Prize in Physics was based on observations of radiation coming to us from the Big Bang. Radiation that's been traveling for almost 14 billion years throughout the universe. And when we look at it, it gives us a picture of what the universe looked like in its infancy 14 billion years ago. It was such a profound discovery that it won the Nobel Prize in Physics. And that radiation has been cooling off from that hot Big Bang, and it now has a temperature of 3 degrees above absolute zero. Precisely what you would predict if the universe is 14 billion years old. When we look out at the sky, we see stars and galaxies. We don't see one galaxy, we see 400 billion galaxies. Each galaxy has hundreds of billions of stars. If all those galaxies were within 6,000 light years of us, so we could see them within 6,000 years, we'd be burned to a crisp. There's no room to fit 400 billion galaxies in such a small size. So you just have to look out with a telescope to know the Earth and the universe is not 6,000 years old. Now, radioactive dating has been argued against in this museum, but it's used all the time. And we can, in fact, measure the life of relatively short-lived things on the time period of about 5 to 10,000 years by using carbon-14 dating. But beyond that, we can date rocks and minerals by using much longer-lived radioactive substances like potassium and thorium and uranium. And they tell us, when we measure them, they tell us that the rocks in the Earth are 4.5 billion years old, which coincides, by the way, precisely with the determined age of the Sun, which is 4.55 billion years old. There are simpler ways to know the Earth isn't 6,000 years old. In 1987, we saw an exploding star on the other side of our galaxy, a supernova, explode. It was 150,000 light years away. That meant the light from it took 150,000 years to get to us.
When astronomers measure hyperfine split lines, we're measuring the velocity of light when the light left that star or galaxy. And astronomers have been routinely making these measurements on millions of different objects. What we see is the identical velocity of light that we measure here on Earth. We've been able to do this to galaxies as far away as 14 billion light years. So the velocity of light has not changed over the past 14 billion years. That's a direct measurement. Now, we can combine it with a theoretical measurement. E equals mc squared. If you make c different, it's going to affect E or m. The velocity of light is a little bit higher for Adam than it is for us. He gets incinerated by the heat of the sun, or you don't have the elements to make Adam in the first place.
If it was closer, again, we would have been burned to a crisp. But we could measure it and determine that everything agreed with the observation that it was 150,000 light years away, meaning that that explosion happened 150,000 years ago, not 6,000 years ago. The fact that the sun shines, we're looking back 1 million years. Well, the light from the sun takes 8 minutes to get to us, but what you may not realize is that the energy emitted in the center of the sun takes 1 million years to get to the surface. If the sun was 6,000 years old, it wouldn't be shining. We can measure continental drift. It's not a hypothesis. We can actually measure with satellites the fact that the continents are separating at the same rate your fingernails are growing, about 5 centimeters a year. And if you work it out, 250 million years ago, the continents were together. Well, when you compare the fossils and the geology of the parts of the different continents that were supposed to have been together, you find out they're identical. Absolutely consistent with the continents having been merged 250 million years ago, and with a constant rate of continental drift that we can measure today. Geology tells us, when we look at rock strata and look at the layers of rocks in the Earth, everywhere on the Earth, it's consistent with a 4.5 billion year old Earth. But if you're not worried about that, if you don't believe the in Antarctica, we can actually take ice cores in Antarctica, and it's like measuring tree rings. As the ice freezes each year, you see a layer. And we can measure back 500,000 years from ice cores in Antarctica. Again, the Earth isn't 6,000 years old. We measure fossils on Earth of varying ages that give us a consistent history of the biology of the planet back to 4 billion years. 100 million years after the Earth formed, life was here on Earth. And the fossil record is overwhelming and vast. It's not sporadic. It's consistent again with an old Earth. Evolution itself has been measured and predicted by measuring the genetic relationships between species. When we do that and we measure the rate of mutations between species, once again we can follow the history of life on Earth back millions of years. So the science tells us in every single way we know that the Earth is older than 6,000 years old.
1905, the official age of the Earth, I've got the textbooks, was 2 billion years. Today it's 4.6.
That's still a lot older than what you're prepared to concede.
From 2 billion to 4.6 billion is a gigantic jump. The fact is they don't know.
The guy who wrote the 2 billion was Edwin Hubble. If you read his paper, 1929, he cautioned people outside of the field to look at this as anything more than a demonstration the universe has expanded over billions of years, because it said his data points are really noisy. This needs to be done with greater precision.
Okay.
We've done that with greater precision. Now we got the number down to better than 10%. Wait a couple of years, we'll get it down to 5%.
You're convinced the Earth is 4.6 billion years old, and that's within 10%.
It's better than that. It's within 1/10 of a percent. 4.57 billion.
It's been challenged within the scientific community itself, and of course if the speed of light gets messed up, then Einstein's relativity theory goes down the tubes, string theory goes down the tubes, all kinds of things go down the tube. And you also were talking, and then I'll let Kent get in here, the fact is apparently there's certain lines that spread out as it gets to us.
You're talking about the idea that maybe Dwayne Gish makes a proposition, for example, that light didn't come from the stars and galaxies. God sent it from an intervening point only 6,000 light years out. But we can prove that's not true through direct observation. As a beam of light travels through space, it passes through dust and gas. What the dust will do is redden the continuum. It's kind of like we see the moon during a forest fire. It gets redder and redder as the smoke gets denser and denser. And as it goes through gas clouds, those gas clouds have movements, and that's going to Doppler broaden the spectral lines. And therefore, a test of whether or not the objects came from the stars and galaxies, are the more distant objects more reddened in the continuum and broader in their spectral lines, and it's a direct proportion. The farther away the object is, the broader the spectral lines, and the deeper the red of the continuum.
Which all means what?
It means the light must have come from the stars and galaxies rather than from some intervening point.
And in measuring that light, you get a time of?
If it came from those distant galaxies, then the light must have been traveling for billions of years, because the velocity of light we can measure and prove theoretically did not change. Okay. Astronomers view the credibility of a young Earth as being much weaker than that for a flat Earth.